We all remember the liquid metal Terminator. But what if that metal was invisible too? A sort of cross between Terminator and Predator.
Transparent aluminum?
That's the ticket, laddie.
Well, in this video, I'm going to make metal as transparent as water. So the alkali metals, lithium, sodium, potassium, rubidium, and cesium, persist in amazing me, especially with their violent and often explosive reaction with water. However, here I'm actually going to do something a little different. I'm just going to take one drop of a mixture of sodium and potassium, which I'm going to use because a mixture of sodium and potassium turns out to be liquid, and that's actually quite easy to handle. I'm just going to react one drop of that with water in a very confined space, and this is what it looks like at 500 frames per second. So the overall reaction is typically written something like this, where the alkali metal reacts with the water to give the alkali hydroxide and hydrogen. But because this is a really confined area and will have consumed up all of the oxygen very quickly, so whatever is burning there isn't hydrogen. Well, so what is that fire? Well, I think what you're looking at here is the potassium actually burning in the steam. In fact, I actually now know it is, because I've since repeated this experiment with steam under an inert argon atmosphere. However, what's really cool is what happens when you do this with much better lighting. Firstly, the metal looks beautiful and shiny, like really, really bright and shiny. But then the surrounding area develops this green color. Well, that's just the color of the potassium gas. Yep, what you're actually looking at there is metallic gas. But then the actual metal itself starts to lose its metallic appearance, and it gets darker and darker and darker until it's really black as evil. And shortly after the reaction with the water finishes and it stops evolving that smoke, the magic happens. And what was, about a second ago, a beautiful shiny drop of metal turns colorless right before your eyes. But it's not finished there. Then, as a finale, it explodes. And I mean really explodes. Now this is incredibly reproducible, and when watched from underneath has an additional trick. It turns out that what was actually black actually turns out was really a very dark blue, and you can see the blue color dissipating and turning colorless. This is the first documentation of this phenomenon that I'm aware of, and what makes it especially interesting is what the hell is that drop at the end? Conventional wisdom would say that it's sodium hydroxide or the alkali metal hydroxide. However, the fundamental problem is this. You see, stuff that's less dense than water floats on water, things like ice and oil, and things that are more dense than water sink. So both sodium and potassium are less dense than water, so they would be expected to float. Sodium hydroxide, however, is significantly more dense than water. It's almost twice as dense than water, and so would sink almost as well as a rock. Further, you can compare the size of the drop of the alloy that's put in there to begin with and the size of the drop at the end, and work out that the drop at the end has about half of the volume of the drop at the beginning. This means that if that drop is sodium hydroxide, then almost as much water has dissolved into the alkali metal as the alkali metal has dissolved into water. But still the problem remains is that sodium hydroxide is completely miscible with water, so if this is sodium hydroxide, why doesn't it sink? Personally, I think that a lot of what you're looking at is simply not included in this equation here. And probably a lot of what's going on here involves species like solvated electrons and hydride ions. Bottom line is, though, no one knows yet. But it's certainly cool to watch a metal first of all turn black and then transparent in less than a second before exploding. Okay, I exploded.
It's a quandary that's perplexing.